So I must tell you this afternoon that we've been informed today that in addition to spreading more quickly, it also now appears that there is some evidence that the new variant, the variant that was first identified in London and the southeast, may be associated with a higher degree of mortality. It's largely the impact of this new variant that means the NHS is under such intense pressure, with another 40,261 positive cases since yesterday. We have 38,562 COVID patients now in hospital. That's 78% higher than the first peak in April. And tragically, there have been a further 1,401 deaths. All current evidence continues to show that both the vaccines we're currently using remain effective both against the old variant and this new variant.
For the number of new infections of the new coronavirus around the world, not related to government state of emergency or vaccination. However, a phenomenon called synchronicity is occurring in a state that transcends physical and spatial elements. Since the birth of humankind, the reason why people develop cold symptoms throughout the year, such as summer and winter, and the change of seasons, is thought to be that the pathogens do not have a certain regularity or predictable order from the beginning. In other words, since the three-dimensional structure is constantly changing, there are multiple factors such as individual differences in the compatibility with the antibody and the process leading to the onset of the disease, and the distribution follows a stochastic distribution. From the beginning, vaccine development is impossible and artificially produced antibodies are ineffective. This is a level that anyone with knowledge at the elementary school or junior high school level can understand. However, the mysterious thing is that no adult can understand it. You're fucking fool. You are insane. In the future, there is a possibility that symptoms similar to dementia will occur frequently, and, in the near future, the symptoms of madness crazy will spread worldwide and become a gathering of crazy madness peoples. At worldwide level, there are infectious agents that are systemic and cause structural abnormalities at the cellular level of tissues. Before it's too late, first, we need to find out what the pathogen is by investigating what is the difference between asymptomatic and symptomatic people. How the Oxford AstraZeneca vaccine works. By Jonathan Coram and Carl Zimmer, updated January 8, 2021. The University of Oxford partnered with the British-Swedish company AstraZeneca to develop and test a coronavirus vaccine known as ChAdOx1-CoV-19 or AS1222. A clinical trial revealed the vaccine was 62 to 90% effective, depending on the initial dosage. Despite some uncertainty over trial results, Britain authorized the vaccine for emergency use in December, and India authorized a version of the vaccine called Covishield on January 3. A piece of the coronavirus. The SARS-CoV-2 virus is studied with proteins that it uses to enter human cells. These so-called spike proteins make a tempting target for potential vaccines and treatments. Spikes. Spike. Protein. Gene. Coronavirus. The Oxford AstraZeneca vaccine based on the virus's genetic instructions for building the spike protein. But unlike the Pfizer-BioNTech and Moderna vaccines, which store the instruction single-stranded RNA, the Oxford vaccine uses double-stranded DNA. DNA inside an adenovirus. The researchers added the gene for the coronavirus spike protein virus called an adenovirus. Adenoviruses are common viruses that typically cause colds or flu-like symptoms. The Oxford AstraZeneca team used a modified version of a chimpanzee adenovirus, known as ChAdOx1. It can enter cells, but it can't replicate inside them. inside. An adenovirus. As 1222 comes out of decades of research on adenovirus-based vaccines. In May, the first one was approved for general use, a vaccine for Ebola, made by Johnson & Johnson. Advanced clinical trials are underway for other diseases, including HIV and Zika. The Oxford-AstraZeneca vaccine for COVID-19 is more rugged than the mRNA vaccines from Pfizer and Moderna. DNA is not as fragile as RNA, and the adenovirus's tough protein coat helps protect the genetic material inside. As a result, the Oxford vaccine doesn't have to stay frozen. The vaccine is expected to last for at least 6 months when refrigerated at 38-46 degrees Fahrenheit to 8 degrees Celsius. Entering a cell. After the vaccine is injected into a person's arm, the adenoviruses bump into cells and latch onto proteins on their surface. The cell engulfs the virus in a bubble and pulls it inside. Once inside, the adenovirus escapes from the bubble and travels to the nucleus, the chamber where the cell's DNA is stored. Adenovirus. Entering the cell. Vaccinated. Cell virus engulfed in a bubble. Leaving the bubble. Injecting mRNA. mRNA. Cell nucleus. The adenovirus pushes its DNA into the nucleus. The adenovirus is engineered so it can't make copies of itself, but the gene for the coronavirus spike protein can be read by the cell and copied into a molecule called messenger RNA, or mRNA. Building spike proteins. The mRNA leaves the nucleus, and the cell's molecules read its sequence and begin assembling spike proteins. Vaccinated. Cell spike protein. mRNA. Translating mRNA. 3 spike proteins combine. Spike. Cell. Nucleus. Spikes. And protein. Fragments. Displaying. Spike protein. Fragments. Protruding. Spikes. Some of the spike proteins produced by the cell form spikes that migrate to its surface and stick out their tips. The vaccinated cells also break up some of the proteins into fragments, which they present on their surface. These protruding spikes and spike protein fragments can then be recognized by the immune system. The adenovirus also provokes the immune system by switching on the cell's alarm systems. The cell sends out warning signals to activate immune cells nearby. By raising this alarm, the Oxford-AstraZeneca vaccine causes the immune system to react more strongly to the spike proteins. Spotting the intruder. When a vaccinated cell dies, the debris contains spike proteins and protein fragments that can then be taken up by a type of immune cell called an antigen-presenting cell. Debris from a dead cell. Engulfing a spike. Antigen-presenting cell. Digesting the proteins. Presenting a spike protein fragment. Helper T cell. The cell presents fragments of the spike protein on its surface. When other cells called helper T cells detect these fragments, the helper T cells can raise the alarm and help marshal other immune cells to fight the infection. Making antibodies. Other immune cells, called B cells, may bump into the coronavirus spikes on the surface of vaccinated cells, or free-floating spike protein fragments. A few of the B cells may be able to lock onto the spike proteins. If these B cells are then activated by helper T cells, they will start to proliferate and pour out antibodies that target the spike protein. Helper T cell. Activating the B cell. Matching surface proteins. Vaccinated cell B cell. Secreted antibodies. Stopping the virus. The antibodies can latch onto coronavirus spikes, mark the virus for destruction, and prevent infection by blocking the spikes from attaching to other cells. Antibodies. Virus killing infected cells. The antigen-presenting cells can also activate another type of immune cell called a killer T cell to seek out and destroy any coronavirus-infected cells that display the spike protein fragments on their surfaces. Antigen-presenting cell. Presenting a spike protein fragment. Activated killer T cell. Infected cell beginning to kill the infected cell. Remembering the virus. The Oxford AstraZeneca vaccine requires 2 doses, given 4 weeks apart, to prime the immune system to fight off the coronavirus. During the clinical trial of the vaccine, the researchers unwittingly gave some volunteers only half a dose. Surprisingly, the vaccine combination in which the first dose was only half strength was 90% effective at preventing COVID-19 in the clinical trial. In contrast, the combination of 2 full-dose shots led to just 62% efficacy. The researchers speculate that the lower first dose did a better job of mimicking the experience of an infection, promoting a stronger immune response when a second dose was administered. First dose. Second dose. 28 days later. Because the vaccine is so new, researchers don't know how long its protection might last. It's possible that in the months after vaccination, the number of antibodies and killer T cells will drop. But the immune system also contains special cells called memory B cells and memory T cells that might retain information about the coronavirus for years or even decades.
Taking me for granted, but you're the first thing on my mind. I'm tired of your excuses, but I could never tell you a lie. Try a little harder, even half as hard as I tried to win you over. Bring me closer to you. Show me what you want me to do. One day you will see, you'll never find another girl like me. One day you'll see, we were always meant to be. One day you will see what it feels like to be me. When I miss you, when I kiss you, when I'm with you. One day you will see.